Okay, so let's balance this equation. We need to make sure that the number of atoms of cobalt and nitrogen, oxygen, hydrogen, and sulfur are the same on the left as they are on the right. So again, I'm going to draw a line at the arrow to divide the equation in my mind. And then I'm going to make a list on the left side of the different elements I have. I have cobalt, and I have nitrogen, and I have oxygen, and I have nitrogen again. I'm not going to list that again. I want to keep all the nitrogens together. And I have hydrogen and sulfur. So those are all the atoms that are present. I don't like the way that cobalt looks, so I'm going to do that one again. CO. Now I'm just going to take inventory. In the first reactant, I have one cobalt atom, and I have 3 nitrogen atoms. There, it says NO3, 3. That means there are 3 nitrate ions. Each nitrate ion has 1 nitrogen, so there's a total of 3. And the oxygens, there's 3 times 3, which is 9. There are no hydrogens in this compound and no sulfur atoms in that compound. And we'll look at the other reactant. No cobalt atoms in that reactant. This says NH4, 2. That means there are 2 polyatomic ions of ammonium, 2 NH4s. So that would be 2 nitrogen atoms. There's no oxygen, and there's 8 hydrogens and 1 sulfur. Now I'm going to take inventory of the products. CO2S3. This has 2 cobalt atoms and no nitrogen atoms, no oxygen atoms, no hydrogen atoms, and 3 sulfur atoms. Getting kind of messy here. NH4NO3. There's no cobalt in that, but there's 2 nitrogens. NH4 is ammonium, that has 1 nitrogen atom, and NO3 has another one. So there's 2 nitrogens. Some of them do that. That would be a little tricky. Oxygens, there's 3 oxygens, O3, H4, 4 hydrogens, and no sulfur. So there's my inventory. I'm going to start at the top. Generally a good place to start. So on the left I have 1 cobalt, on the right I have 2. I need there to be 2 cobalts on the left. I can't take away, I can only make there to be more. I can add things. So I'm going to put a coefficient of 2 in front of cobalt nitrate. That multiplies the entire thing. So all the numbers listed below are going to be multiplied by 3. So, multiplied by 2. There's 2 cobalt nitrates. So this number 1 becomes a 2. And 2 times 3 is 6. And 2 times 9 is 18. 2 times 0 and 2 times 0, those are still 0. So now I've got my cobalts balanced, 2 on each side. Now I need to look at nitrogen. On the left I have 6 plus 2, which is 8 nitrogen atoms. On the right side I have 2 nitrogen atoms. So I could put a 4 in front of the ammonium nitrate because that will multiply everything in it by 4. 4 times 0 is 0 still. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16, and 4 times 0 is still 0. Now that didn't mess up the cobalt, so I'm safe. So now I've got cobalt and nitrogen taken care of. I need to check out the oxygens. So on the left I have 18 oxygens, all in that one reactant, and on the right side I have 12 oxygens. And that doesn't look good, does it? There's not an obvious way to fix that. So I'm going to skip that one. I'm going to go on to the hydrogens. There are 8 hydrogens on the left and 8 hydrogens on the left and twice as many, or 16, on the right. Well, that's something I can fix. So if I put a 2 here, because that compound has 8 hydrogens in it, I'm going to multiply everything here by 2. So I'm going to end up with a 4 here, and a 16 here, and a 2 there. So I straightened out my hydrogens, but now I screwed up my nitrogens. And so then we say, what to do? Well, let's go back and look at the nitrogens. Now I have 6 plus 4, which equals 10. On the product side now, I have 8. Can I make there be 10? Well, if instead of multiplying by 4, if I multiplied by 5, then the nitrogens would come out, but that would end up changing the hydrogens. And so we see, oh, it looks like we're getting into something ugly. So then we think, you know what? This isn't looking good. Let's go back and start over again. So there, through the magic of technology, I have gone back to where we started from with just the inventory. So we learned on that one that starting at the top and going down, things got ugly. So we're going to try starting somewhere else, maybe at the bottom. We've got nitrogens all over the place, and so those are something that we should really be leaving for later. Let's start at the bottom with sulfur. On the left we have 1 sulfur, and on the right we have 3 sulfurs. So let's multiply this by 3, the NH42S. That will multiply everything underneath it by 3. So we'll end up with 3 sulfurs and 24 hydrogens. Don't be afraid of that big number. And 6 nitrogens. All the numbers in that inventory list get multiplied by 3. Now let's go up and look at the next one up, which is hydrogen. Hydrogen, now there are 24 on the left and only 4 on the right. Well, if we multiply 4 by 6, we'll get 24. So we're going to put a 6 in here as the coefficient for ammonium nitrate. The 6 multiplies all the coefficients beneath it. So the 2 becomes a 12, the 3 becomes an 18, and the 4 becomes a 24. That didn't mess up our sulfurs, so we've got sulfur taken care of, and we've got hydrogen taken care of. Now let's look at the oxygen. Okay, on the right we have 18 oxygens, on the left we have 9. So if we multiply 9 by 2, we'll get 18. So we'll put a 2 coefficient in front of cobalt nitrate. That multiplies everything underneath by 2. So we've got 2 and 6 and 18. That didn't change the hydrogens and sulfurs, which we had already balanced. So now we've got our oxygens balanced. Now let's check our nitrogens. We have 6 plus 6 on the left and 0 plus 12 on the right. That's equal. And so we'll check our cobalts, 2 plus 0 and 2 plus 0. The thing is balanced. And that's a good illustration of how the element that you start with can often affect how easy it is to balance. If you start with one element and you're working your way along and things get ugly, stop and just start over again with something else, and it'll probably work better.